Hello, everybody, and welcome again to my home. I am Patrick Rowley from the James E. Richmond Science Center, here for another episode of our Science on the Sphere at Home, using NOAA's Science on the Sphere Explorer, or SOSx app that you can get for your tablet or phone. So last week we were looking at water. The year before, or the week before that, it just seems like a year. The week before that, we were looking at air, satellites before that. This week, we're going to be looking in the land category of the app. So we're going to start with this one here that's kind of washed out on my screen, and that is age of the sea floor. So I'm going to pull that up onto the screen so you can actually see it. All right, there we go. So like I said, we're looking at age of the sea floor. This is a pretty neat data set, again, in the land category. And it allows us to see different types of plate boundaries and how that influences the age of the bottom of the ocean, the sea floor there. And this is actually designed by the School of Geosciences at the University of Sydney in Australia. And it's through NOAA's Geophysical Data Center is how they gather the data for this project. And so as we spin the Earth around, you see all these different colors here, right? And so what we can see are in the red areas, we have pretty young sea floor, okay? Like right here. This is along the mid-Atlantic ridge, middle of the Atlantic Ocean. And that is what we call a divergent boundary, meaning that these two plates here, you see on like the North American plate, the African plate, for example, where they are diverging or moving apart, all right? So what that does is allows some magma from just below the surface there, or the surface of the ocean floor, to kind of ooze up out of the ground. It's not necessarily like a volcanic eruption. The magma oozes up slowly and hardens with the cool ocean water there and becomes new sea floor. So it's pretty young by those standards, right? So it's could be as little as 0 million years old, right? Up to several tens of millions of years old. So that is where we have some pretty young. Now you'll notice as we go farther away, it gets older and older and older because that has started to move apart as these plates continue to move, all right? If we go around, however, to other areas of the world, you'll notice we even have some kind of bluish areas where it is showing up as much younger, all right? And so what we have there is some subduction zones where we have a convergent boundary, all right, where the two plates are pushing together. Now, sometimes you can have convergent like up around here at the top part of the Indian plate, creating the Himalayas. All right, the mountains there. And so you have pretty equal densities of rock, of land, and so it forms a mountain, right? So they push together and form a mountain. Other areas of the world, like especially all around the Pacific Ocean here, we end up having some subduction zones where you have a more dense rock that kind of gets pushed down below the other rock, right? And it disappears. So where you would have had some really old rock, it's gone, all right? And you'll notice we don't have a whole lot of the really, really blue stuff. There's some hints of it in this area that we're looking at here, but not a whole lot. And that's because that really old rock has gotten pushed down below, all right? But along that plate boundary, we still have some pretty old rock, all right? And there's very little on the map here that's actually over 150 million years old, all right? Now, some areas of the world, it's kind of just this area where, here's some area where we have some of that really old rock there as well. It hasn't changed a whole lot. It's on the edge of that where the plates are moving around as well, all right? Now, one thing to notice is we talked about divergent, convergent. There's another one called transform boundary, where they're not really pulling apart or squeezing together. The plates are just sliding right next to each other. So it doesn't really influence the age all that much. It will just continue to age that way as well. All right, so next up in our land category is related to this. We're going to be looking at earthquake locations, okay? And so what this data set does is it kind of animates earthquakes from 2001 to 2015, so about a 15-year period. And we have the different size dots and the colors, all right? And the colors indicate the earthquake depth, how far down that earthquake occurred. The size of the dot indicates how big the magnitude of that earthquake was, all right? So if we go around here, you can kind of see our scale there, starting with 7 up to 9, and the ones that are smaller, obviously, are even smaller than 7, okay? And so we can see where these earthquakes were occurring. And what's interesting is we can really get an idea of where most of the earthquakes on Earth occur. And let's see, do I have? No, I don't. All right. But if we look back, if we think back to the last one, you saw those plate boundaries, the tectonic plates. Most of these earthquakes are happening along those tectonic plate boundaries. They're pretty small here in that mid-Atlantic ridge we talked about. It's divergent, so there's not as much energy that needs to be released compared to some of these really big earthquakes all along these convergent boundaries around the Pacific Ocean, for example. So you'll really see that they're not just spread out evenly around the world. These earthquakes are happening primarily along these plate boundaries. And lastly, we're going to finish up with a different kind of data set. This is looking at land use, all right? So this is agriculture, food versus feed, okay? So the green areas are areas where crops, food is being grown to feed humans, us, right? Whereas red are areas that are where the food is being grown to feed animals, like livestock, right? Which most of them become food for us as well. And then orange is kind of equal there. Now what's interesting, and the reason this is important to look at on a global scale, if we look here, a lot of the US's, the land use is being used to grow food, not for people to eat, but for livestock to eat. And it takes 30 pounds of this feed to produce just 1 pound of beef with cattle, for example, right? So it's really not the most efficient way to provide food for ourselves. Now, I'm not a vegetarian. I love steak. I like burgers, right? But it's something to consider about potentially lessening how much meat you eat because of the environmental impact here and of providing enough food for the world, right? Compare that to India here, where almost all of their land is being used to provide food for humans, right? So it's definitely a different type of structure there. And that's all I've got for you this week. Thank you for joining me again for another Science on the Sphere at Home episode. Next week, we'll be looking at people and life in general, all right? So we've covered air, the water, land. Next week, we'll be looking at life, all right? So look forward to seeing you then.